I tried that.
Did you have to download that again? So I'm gonna call Jen. Ask him to come up.
And then it gives me. Yeah, I mean, if they cannot connect to the receiver.
Should I call and see if they're having issues with mirror up?
Yeah, that's fine. So we'll see what's going on with that. In the back.
All right. Hey, we gotta get back in the habits. We got everybody with their phones up here. Who's missing? I know we're missing a few people. Zach. Juan. You have a phone? No. Damien's not here. Emily? No. What? Mason, there we go. Maddie. Jenna's not here. Reese. Riley's not here. All right, that'd be it. Good.
Well, I probably had like the first Saturday.
All right, we kind of got through the first three sections of chapter 5. That was solving systems. We graphed them. We did the Desmos. We did elimination. We did substitution. We're still going to know how to have to do this for 5-4. We're not going to have a big chapter 5 test, just kind of how it was broken up. We're going to go from 5-4, 5-5. These are some things we're not going to cover. And then we'll hit 5-6 and 5-7. So we're going to hit those there this week. Dealing still a little bit with graphing. All right, it says solve linear systems with different number of solutions. All right, a system. Remember, it's going to be two equations with two unknowns. Okay, this is a system. Okay, so you see that first one there. We want to find any ordered pairs that work for both of them. To this point, we've kind of limited your options on purpose. But now we're going to throw everything at you. There's three things that can happen when you're solving a linear system. Each equation is going to be a line. The first thing that can happen, okay, as you see up there, is you can have two lines that cross at a point. They now call that point whatever and say -2, 1. That is the solution to the system. If they cross at a point, there's one solution. Can those two lines hit at any other point? No. Okay, they're straight lines. They can't turn.
Hey guys, I would write under there, like, they have to have a different slope. It's right to underline that. Highlight that. Lines intersect, they have to have a different slope.
And so that is the key. So now what are two lines that have different slopes? What does that look like? Well, the first line might be y equals 2x plus 1. And as long as the next line has a different slope. All right, it's been a while. Which number is the slope? The one with the x. So the 2 is the slope. I just have to have a different number in front of the 2. So if my next one is y equals 3x minus 1, I know those two lines have different slopes. They have to cross somewhere. And that's going to be my solution. All right. No solution. If you get parallel lines, well, we've talked about this before. Parallel lines, what has to be true about their slopes? Same, right? So they have to have the same slope, but they have to have different y-intercepts. So you might get y equals 2x plus 4. What would be a line parallel to that? Yes, Griff.
Y equals 2x plus 6.
Y equals 2x plus 6. Yep, you just have to have a different y-intercept.
Guys, this is the new 9 weeks. I'm going around. Look at some of you, know your grades. Everything we write down, you guys should be writing this stuff down on your notes to help you. half the people aren't even writing this stuff down, the examples he's given. I don't understand why, guys.
So you get this stuff down so you can look back, you can review it. All right, this one can throw you at times. Infinitely many solutions. Infinitely many solutions. The lines are exactly the same. Okay, there's really two lines. One is right on top of the other. Now for that, it might be y equals 2x plus 4, and the other equation would be the same. Now you would, if you were given to, you'd know they're the same, but they're going to disguise it. It's not going to look exactly the same they initially give it to you. So for example, I'll tell you that the first one might be y equals 2x plus 4, but the next one might be negative 2x plus y equals 4. They're going to move it around a little bit. Okay, where it's not just the same two equations. Okay, and you'll see where that comes up. If they cross, one solution. This is the only one we've done to this point. Everything we've had is at one solution. Now we're going to introduce a case. It can be no solution or infinite many solutions. Okay, this one, nothing works. Here, every point on the line works. So this first one here, this is the only one we're going to graph. Okay, I still want you to graph it, even if you look at it and you know the answer. All right, y equals 2x plus 1, y equals 2x minus 5. Can anybody tell me the answer?
Like if it's one solution?
Yeah, is it one solution? Is it infinitely many solutions, or is it no solution?
One solution?
What makes it one solution? What's the key that we wrote down?
The slope's different.
Okay, what's the slope for the first one?
2.
What's the slope for the second one?
2.
So are the slopes different?
Oh,
No, they're the same. Do they have different y-intercepts?
Yeah.
So what's that tell me?
No solution.
No solution. It's going to be parallel lines. We still need to graph it now because we got to review our graphing. So y equals 2x plus 1. Jeff, what is the slope of that one?
2.
Good. It is 2 or 2 over 1. It is a positive slope, so it has to be going uphill. What is my y-intercept, Zach Abbott? 1. Okay, now remember our y-intercept is we call the b value. So you go to 0, 1. That's where we always start. You put a dot there. 0, 1, put a dot. And then you go up 2, and then to get a positive slope, increasing slope, you go up 2, and you got to go to the right 1. So I go up 2 to the right 1, up 2 to the right 1, and then you can go down 2 to the left 1. Connect those, extend it. Now the other one is y equals 2x minus 5. All right, Addie, what would be my slope for that one?
2x.
Just not the x,
Just
just the 2. And I'm gonna write this 2 over 1. It's a positive slope, so it's going uphill. All right, just kind of make sure we remember all this. Maya, what is the y-intercept? Oh, we're on this. We're on this equation here. 2x minus 5.
Isn't it 5?
Negative 5. Make sure you put the negative 5. So your y-intercept is 0, negative 5. All right, so we graph that. You go to negative 5, and we go up 2 to the right 1, down 2 to the left 1, and we connect. Now, a lot of times you're going to see that and say, hey, I know the answer. Well, if it asks you to graph it, you still got to graph it. I need to see 2 lines on there. One going through 1, one going through negative 5, making sure that they're parallel. Now, it says solve the system. You're going to put no solution. You're going to put no solution. Okay, for that. The answer is where they cross. They don't cross. No solution. Okay, so make sure you got both lines. Make sure you got that graph. All right, now, who can tell me the other 2 ways we solve systems? It's been a while. One starts with an S, one starts with an E.
Substitution and elimination.
Substitution, elimination. We can still use those. We're going to use those for the other cases. Now, you look at this one. You cannot tell me the slope till you get y by itself. So this is not as obvious. Okay, it's not as obvious whether this is going to be if they're going to intersect or if they're going to be parallel, if they're going to be the same line. We can use substitution or elimination. To use elimination, remember, you have to get something to add up to 0. Will either of these add up to 0? Will the x's or the y's add up to 0? Aiden? No. Who can tell me how to make them add up to 0? Remember that process, Griffin?
Add 2x to other side.
No, I'm not going to move anything.
Oh.
I don't need to move anything. We can do it right from here. We got to do one thing. Gavin?
Multiply -2 on top.
Yeah, if this is a negative 4x, to add up to 0, it'd be great if that was a positive 4x. So you make it a positive 4x. Okay? So that's one on the right. So now I'm going to multiply this top one by -2. When you multiply it by -2, you multiply everything by -2. -2 times -2 is 4x. -2 times positive y is -2y. And then -2 times 3 is -6. I get -4x. The other one I don't need to change anything on. Now remember, we add straight down. We add straight down. What happens? What's 4x minus 4x? 0. What's -2y plus 2y? 0. What's -6 plus 6?
0.
0. All right, so what am I left with? I'm left with, here's what you're left with. 0 equals 0. Okay? Does 0 equal 0?
Mm-hmm.
Yeah, that's true. Okay, if this is true, that means that these two are the same line. Okay, look, they're really the same, except this one has all the opposite signs. Okay, they're the same line. That means they overlap each other, which means we have, what is our answer? Right.
Many solutions.
Many solutions. And I'm going to put infinitely many solutions. So our answer is there's infinite solutions. Okay, I'm going to give you a little heads up what it would look like if it was no solution. If you're solving it this way, if you're not graphing it. If you end up with any true statement, 0 equals 0, that's true. That's going to be infinite solutions. If I would end up with something, say 0 equals 8, that is false. That means that there are no solutions, okay? So we can end up with either case. It means they're parallel lines. So we'll see if we come up with one of those here. All right, C, you got the same thing there for C? This one is set up not for elimination, but this is kind of set up for what method? Substitution, because I already have the y by itself. I got y alone. And I don't want, you cannot add them vertically unless they are all lined up. So I'm going to do substitution here. I'm going to take -x plus 3, and where do we plug that in for? You plug that in for not x, but y, because it says y equals. And so underneath there, the 2x will stay the same. This becomes 2 times -x plus 3 equals 4. So we're going to use substitution. Now, when you have that 2 in front of that parenthesis, you got to distribute it. The first 2x stays the same. 2 times -x. That can be just written as -2x. 2 times 3 is +6 equals 4. Hey, now we just do everything we've done the same before. We don't change anything. We just simplify, combine like terms. All right, but what happens? What does that leave us? And don't move that 6 yet. I would keep that right there. What's 2x minus 2x give me? 0. What am I left with? Juan, what do you think? 6 equals 4. Okay, this is a case. There's a temptation to write down an x because you think you always have to have an x. If it's 2x minus 2x, that is 0. It is gone. That just leaves us 6 equals 4 like Juan said. All right, now we're going back to what I just talked about. Does 6 equal 4? No, that means that it is. If we would graph them and we would end up with parallel lines, that means this is no solution. So if our x's end up dropping out, or everything ends up dropping out, you're either going to get infinite solutions or you're going to get no solution. Okay, infinite solutions or no solution. So no solution for this case because this is false. Okay, that's false. The difference 0 equals 0. That's true. That is infinite solutions. All right, now D there. And if it doesn't say substitution or elimination, you technically can use either method. I think they're more set up for one or the other. That's kind of why we did substitution on this last one. If everything's lined up, I would use elimination. Okay, if everything's lined up. All right, what do I have to multiply by to get something to add up to 0? Okay, Ellie?
-2.
-2. So take your top one. Multiply it by -2. Everything. Now, whenever I multiply, I like to go to the right. And I get -2x minus 2y equals -6. The other one doesn't change. All right, what happens when you add? What's the whole left-hand side equal? 0. What's the whole right-hand side equal?
0.
0. So we get the 0 equals 0 case. Okay, and so that's going to be infinite solutions. These are going to be the same. That tells me that those are the same line. Your answer is infinite solutions. That's just making sure you understand how to relate those. Okay. All right. First day back. Want to give you some extra time here. Get this either done or close to done. Page 267, 2 through 6 all. So not a lot of problems. So keep your notes out. Don't put those away, Alex. Keep your notes out and use them. I'm going to talk to a few individually. Yeah, I got you. I just got it. They don't have to. Yeah, I'll send it to you.
Thank you, sir.
Hey, you do not have to graph any of these. Okay? And it says explain your choice of method. I'll note, just use substitution or elimination. You don't have to explain why in terms of that. All right, now I'm going to call a few of you out to go over grades.